Okay, so chapter 2 is based on the principle that says, okay, um, if you can still remember, the nearby dollar is worth more than a distant dollar. So we discussed that one before we ended up with that chapter. And that is very important here because that is the foundation, that is the principle, um, the foundation of chapter 2, which is time value of money. Okay, so um, time has value in that affects money. And why is it that the distant dollar is worth more than, why is it the nearby dollar is worth more than the distant dollar? Okay, so that is the one that we are going to discuss today. Okay, there are several reasons why we have time value of money. Actually, there are three main reasons why we have time value of money. And what is the first? Okay, the first is we have the cost of, okay, so the first reason why we have time value of money is because of the cost of the cost of money. So money has cost. Okay, and what is that cost? Okay, if you go to the page of your book, so if you have the book, so let's try to see. Okay, so you have here. So to describe the cost of money, we have interest. Okay, what is the meaning of interest here? Okay, so interest, okay, it is defined as, are you there in this page? So this is the definition of
Yes.
interest. Oh, okay. Okay, so we see here the definition of interest. It is defined as the cost of having money available for use. So that is the definition of interest. And the rate is called as the interest rate. So that is the percentage that that is periodically applied and added to the amount. Okay, so interest is measured by the interest rate. That's why um, you have heard about 5% interest rate or 10% interest rate. So this is the first reason why we have time value of money, because we compute the cost of money over time. Okay, and okay, just to clarify, because maybe because in Arabic there are two definitions of interest. One is faida, and you know already that the other one is reba. Okay, so what we are talking about here is the faida. Okay, because in the previous years, some of the students said, "Oh, maybe that is reba." Well, it is not. It is the faida, the cost of money for use. So that is one of the reasons why we have time value of money. So cost of money. Now, remember in our discussions on the principles of economics, there are several types of resources. So what are the different types of resources? So we have land, labor, capital, and entrepreneurship. Now let's consider capital. Okay, so we define capital as one of the resources that is finished goods that we use in order to create another good. And what are examples of capital? Aside from the investment or money that we invest that is considered as capital. So aside from that, what are other examples of capital? Okay, some examples of capital are we have machines, tools, buildings, factories. These are considered as capital. Okay, now let's consider one capital, which is a commercial building. Now, what is the purpose of commercial building? That is for business stalls, for renting. So these are available for rent. Okay. Now, suppose you are going to use my building, so you need to pay the rent. There is a payment, and usually the rent is in terms of periods, like for example, monthly or yearly or by annual. So these are the terms that we use to pay the rent. Now, since investment is also a capital, if somebody is going to use your capital, he should pay also the rent, same as the building. When you use the building of the others, you need to pay the rent of the building. And since we consider the investment as capital, if somebody is going to borrow or to use the capital or investment or the money you invested, then for sure there is a corresponding payment for that capital. And what is the rent or what is the payment for the use of the capital that is money? That is now what we call as interest. So the one that we defined earlier in based on our book. So that is interest. So that is the payment for the use of money, because money is also considered as capital. Okay, any clarification for that? So the first reason why we have time value of money is because there is a need for the capital to be paid. If you're going to use the capital, we need to pay the capital, and we call that as interest. Okay, so that is the first one. And take note that the payment of the rent for the capital is through for some periods. It is periodic. It can be monthly, it can be yearly, or it can be biannual. Okay, so that is the cost of money. And then the second one is we have inflation. Now, we know already that inflation is the general increase in prices. General increase in prices. Okay, how does inflation affects the purchasing power of money? So here we have what we call as purchasing power. So what is the purchasing power? Purchasing power is the ability of your money to to acquire goods and services. Like for example, if you have 100, so your 100 reals has the ability to buy something. Or if you have 1,000, for example, your 1,000 has the ability to buy mobile phones, has the ability to buy laptops, has the ability to buy food, and so on and so forth. Okay? So we call that as the purchasing power of your money. Okay, aside from purchasing power of money, inflation has something to do with this because we consider here that money has also what we call as earning power. Money has the ability to earn. That's why it has what we call as earning power. Okay, now to illustrate this thing, suppose you have 100 reals. Okay, that is the only money that you have, for example, and you want to buy a refrigerator, and the worth of refrigerator is 100. So this is the money that you have, and the worth of the refrigerator now is 100. Now, if you are going to buy the refrigerator now, what will happen to you? You will end up broke, meaning because you are going to use your 100 to buy that refrigerator, so you will end up zero money. Of course, you have the refrigerator, but you will end up zero money because the worth of the refrigerator is 100. Now, suppose you decided to put your money in a bank. Okay, so instead of buying the refrigerator, you decided to invest your money in a bank. And the bank offers 6% interest rate per year. So this is so what is the 6%? 6% is the earning power of your money because that is what the bank is offering you. So if your money is earning 6% and you invested 100 after a year, what happened to your money? Your money earned how much? 6% of 100 is 6. So at the end of the year, you have 106. Okay, but suppose there during the year there is inflation and the inflation is 8%. So inflation is 8%. Now, if you want to buy the refrigerator after 1 year, can you buy the refrigerator? What happened to the price of refrigerator? Because there is inflation, there is an increase in the price of 8%. So instead of 100, the price now increased. It became 108. Okay, now compare before 1 year. So before 1 year, your money has the power to buy the refrigerator. The only thing is you will end up broke or you will not have you will have zero money after that. But what happened after 1 year? Okay, your money has earning power of 6%. After 1 year, it became 106. But there was an inflation during that year of 8%. That's why the price of the refrigerator after 1 year is now 108. So what happened? You cannot buy it anymore. Compared to 1 year before, you can still buy the refrigerator, but after 1 year, you cannot buy it anymore because what you have is 106 and the price of the refrigerator is 108. So you need 2 reals more to buy that refrigerator. So here, the first concept that we have in relation to inflation is that If the inflation rate is higher than the earning rate, the purchasing power of your money will decrease. I repeat, if the inflation rate is higher than the earning power of your money, the purchasing power of your money will decrease. So you see the purchasing power, it is same as 100, but what happened? Its purchasing power has been reduced. Why it is reduced? Because this time it cannot buy anymore the thing that it can buy 1 year before. So as we say, if the inflation rate is higher than the earning power of money, the purchasing power of money will decrease. So you see, a matter of 1 year. So there is a time element before the purchasing power decreased. Okay, on the opposite side, if, for example, the earning power is still 6%, but the inflation rate is only 4% during the year, so what happened? The price of the refrigerator increased, but it is only 104 because the interest rate is only the inflation is only 4%. So what happened if the inflation rate is lower than the earning power of money? Your purchasing power became more powerful because this time, okay, compared to 1 year before, that if you bought the refrigerator, you will end up broke or no money. But after 1 year, when the earning power was 6% and the inflation rate is 4%, what happened? You can buy the refrigerator and still you have 2 reals left on you. So you see the effect of inflation in a matter of 1 year. What happened? So it determined the purchasing power of your money. So with this purchasing power of money, it is affected by the time element. That's why there is what we call as time value of money. Okay, so this is inflation. The third is compensation of the risk. Every time that we invest our money, there is always risk. So they say in business, you cannot avoid risk. That is what we are saying, that in engineering economics, there are two elements, uncertainty and time. So how about risk? So the interest or the time value of money is the compensation of the risk when we take the risk. So when we invest the money, there is a risk. That's why we need to put interest on it. Can you imagine if your friend, even if your friend is going to borrow, for example, 2 million reals, and he said he's going to pay it after 1 year. So during the span of 1 year that he is not yet paying, so count the number of days that you are not yet receive your money, because he said, he promised, I will pay you after 1 year. So 1 year that there are risks that maybe he cannot pay you after 1 year. So that is possible. So it is very risky. And take note that that is 2 million. Well, even for example, 10,000, it is already risky to okay, to let other people use your money. So how many days it will be risky? Because every day that he is not yet paying your money, there is risk that we are talking about. Suppose there's something happened to your friend who borrowed your money. There is a possibility that you will not take back anymore your money. So that is now the risk. And to compensate the risk, you need to put interest on it because of the risk, a compensation for the risk. Okay, so that is yes, risk and interest have directly proportional, not exactly direct, but these are some of the reasons why we need to apply time value of money. No, is this Anna's? So according to our schedule, can you check in the announcement? Because we have two periods. Yes. Okay, you're right, Omar. Thank you for checking. Okay, so these are the reasons why we have time value of money. The first is the cost of money. So money has cost. So whenever we use money, there is a corresponding payment for the use of the money. And then second, the time value of money is affected by inflation. It can lower or it can increase the purchasing power of money. That's why usually because of inflation, your 100 after several years, the worth is not anymore same as the worth it has before. So that means to say it is the same money, but the purchasing power changes over time. And the third one is risk. So to compensate for the risk, when we let others use our money, every day that he is not yet paying, there is always a risk, and the interest is the one that compensates it. Is it there already, Abdurrahman? Okay, let me check. Sorry for that. Yeah, it should be. I think. Okay, it should be 9 9:40. Sorry for that. Somebody have taken already? Okay, so that is the cost of money. Okay, let's move on. Okay, so let's move on to the elements of transactions involving interest. So there are only few elements. That's why engineering economics is not that difficult because we only involve six elements in the transaction. And what are these elements in the transaction? So first, we have the principal, or this is what we call as P. So this is our P, or we call this as principal. This is the amount of money invested or borrowed in a transaction called principal. So this is initial, the initial amount of money invested or the initial amount of money borrowed. So take note that the cash flow has two sides. So the first one is cash in and the second one is cash out. So when we say cash in, money is coming in, and when we say cash out, money is going out. Okay. So for example, if you are going to deposit your money in a bank, so the amount of your deposit is considered as P, or that is considered as the principal. That is the initial amount of investment. Likewise, if you obtain a loan from the bank, so if you receive that loan, that is considered as principal. Okay, so the first element is principal. The second element is interest, or it is the small letter I. By the way, in our course, there is a difference between the small I and the capital I. So the capital I is the interest and the small I is the interest rate. So the second element is the interest rate. It is the small letter I. So it is the measure, the cost or price of money, and it is expressed as a percentage per period of time. So we call this as interest rate. Okay, third element. Okay, this is small letter n. Okay, also letter n. So the small letter n is different from capital N. Okay, what is the difference between small letter n and capital N? So the third element is small letter n. And what is this? So this is a period of time called interest period. So small letter n is interest period, and it determines how frequently interest is calculated. Okay, so how many times interest is calculated? So normally, interest is calculated yearly, so every year. That's why if you are going to invest your money in a particular investment, the calculation of the interest of your money is determined every year at the end of the year. Okay? So that means to say N is yearly. Okay, how about number four element? So number four element is capital N. And capital N represents the duration of the transaction. So number four is the specified length of time mark the duration of the transactions and thereby establishes a certain number of interest periods. So capital N is the interest period, while small letter n is the interest. Sorry, capital N is the number of interest period, and the small letter n is interest period. So there is a link. There is a relationship between n, small letter n, and capital N. So capital, um, for example, capital N is 5, and the small letter n is yearly. So that 5 as capital N means 5 years. But if small letter n is monthly and the capital N is equal to 12, that means that is 12 months. The duration is 12 months. So it is important that, this one should conform. So number 3 should conform with number 4. And number 5 is the plan for receipts or disbursements. Okay, in this case, I usually remove the sub n here. So just put it as A because A sub n have a different meaning in chapter 4. So not to confuse you, that's why we need just to use capital A. So this is also called as amortization, or sometimes this is equivalent to equal payments, or we call this as installment. That is capital letter A. And number 6 is the future amount of money F. And it says here it is the result from the cumulative effects of the interest rate over a number of interest periods. So this is the amount of the accumulated, accumulated amount plus the interest. So we call this as the F, or future amount of money. So let's summarize. Okay, what are the 6 elements involving interest? Because these are the variables and these are the elements that we are going to use almost all throughout of our course. So P is the principal, or usually we call this as the present value. Principal or present value. And then we have the interest rate, the small letter I. And number 3 is small letter n. That is the interest period that specifies how frequently the interest is going to be calculated. It can be yearly, monthly, quarterly, or semi-annually. And then we have the capital N that represents the number of interest period. And number 5 is A, or we call this as receipts or disbursement, plan for receipts or disbursement. And sometimes we call this as the installment or equal amount of payments. And then we have number 6, which is the future amount of money. Okay, now we have an example here so that we can apply the different elements of transaction. Okay, we have example of interest transaction. Let's read, and then we need to identify Muhammad. A is plan for receipts or disbursement, or the other term for that one is equal amount of payment, or we call that as equal periodic payment, or sometimes we call that as installment. So that is the name of, that is what A represents. Okay, but here it says a plan for receipts or disbursement or equal equal periodic payment. Okay, so let's have the example so that we can understand what are these elements of transaction. So here we have example of interest transaction, and it says here, okay, let's start from here. Okay, it says, suppose that you apply for an education loan in the amount of 30,000 from a bank at 9% annual interest rate. In addition, you pay 300 loan origination fee, or sometimes we call this as documentation fee or administrative fee. Okay, that is 300 loan origination fee when the loan commences. Now, the bank offers two repayment plan, one with equal payments made at the end of every year for the next 5 years, or we call that as installment plan, and the other with a single payment made after the loan period of 5 years, or that is called as deferment plan. Okay, so these payment plans are summarized in table 2.1. Okay, what is this example all about? So it says here, suppose you apply for an education loan amounting to $30,000. So what is 30,000 here? So remember, you apply for a loan. So when they give you the loan, you will receive the loan. That is the initial receipt of the loan. So you will receive now the loan. Therefore, 30,000 here is considered as our P. So we can write here, our P is equal to 30,000. And it says here, okay, a 9% annual interest rate. So small letter I is 9%. And it says here, 9% annual interest rate. In other words, the small letter n is annual. So how often we calculate the interest? It is every year. So the calculation of the interest is every year. And usually it is at the end of the year. Okay, now on the repayment, okay, on the repayment plan, it says here, the bank offers two repayment plans, one with equal payments. Okay, take note of the word equal payments. One with equal payments made at the end of every year. So therefore, that is equal payments, that is A. So A is, how much is the equal payments here? Okay, so A is equal to 7,712.77. And how about the other one? So plan one is, okay, and plan two, it says here, it is considered as deferment plan. You are going only to pay after 5 years. And usually that is lump sum also. Here, it is considered as F, and that is 46,158.72. Okay, so did we identify all the necessary elements? So we have a small letter n, that is annual, and the capital N is 5. That means to say the duration of the loan is 5 years. Uh, I think Muhammad, yes, principal or present value, the 30,000. So once you receive the loan, that is the initial amount that you receive. That's why it is considered as P. Okay, so do you have any question on the transactions? So you can see that one also in the table. Okay, so year zero is usually now. Okay, now you receive 30,000. That's why it is considered as P. And of course, you borrow that money, so you need to return that. How you are going to return? So there are two repayment plans. So the first plan is what we call as installment plan. Remember A, or installment or annual equal payments? And how much is the annual equal payments, or how much is the A? That is 7,712.77. So you see here the plan. Every year, you are going to pay 7,712.77 so that you can repay the loan. The other option is you defer the payment. You only pay the loan after 5 years. And how much you are going to pay after 5 years, this is the amount that you are going to pay. So that is, we defer the payment. Okay, so before we end, okay, our session for today, it is always important that we are going to graph the transactions to help us analyze later on. So sometimes even me, I am familiar with the transactions already. I still use the diagram. We call this as the cash flow diagram to represent the transactions so that I can analyze correctly and accurately. So we use the tool cash flow diagram, and the cash flow diagram it is the graphic representation of the transaction. This is a very simple graph. Okay, um, all we have to do is to draw. Okay, all we have to do is to draw a horizontal line, and then we need to tick the years starting from year zero going to the right. So we have 1, 2, 3, 4, 5. So we have 5 years. Our n is equal to 5, and our small letter n is annual. Therefore, these numbers here in the diagram are considered as years. Okay. Now, take note that we need also to represent the flow of the cash. As I said a while ago, we have cash in and we have cash out. So what happened in year zero is that we received the loan. Is it cash in or cash out? So we have two types, cash in or cash out. So when we say cash in, the cash is coming to us. It is going to our pocket. But if we take the cash out of our pocket, like payment, then that is considered as cash out. Now, the cash in the cash flow diagram is represented by, so cash in is represented by arrow up. So this is cash in. And arrow down is cash out. So when we receive the loan, so Muhammad said it is cash in. Also Abdullah said cash in, and they are correct. So therefore, we need to represent that transaction by, okay, it is an arrow up, and then we put 30,000. But at the same time, when we receive the loan, we need to pay the documentation fee or administrative fee amounting to, how much is that? 30,000? Um, that is 300. Okay. So we need to pay the 300 because that is payment. Then we need to put that as 300. But you see, we do not have a cash flow diagram with both directions. So there is only one per period. What we are going to do, we need to compute the net cash flow. So the net cash flow is the difference between the cash in and the cash out. So here, 30,000 minus 300. 30,000 minus 300 is 29,700. Yes. So therefore, we need only to put 1. And we will put that in the direction that is greater. Therefore, we need to erase this, and then we need to put that here. That is 29,700. Okay. Now we need to represent first the plan number 2. That is deferment or lump sum. So what happened? After 5 years, that is the only time that we are going to pay the, how much is the amount of that? That is 46,158.72. Okay. So that is the representation of that transaction. That is option number 2 or plan number 2. So you see here that we do not have, sorry, in this period, we do not have other transactions other than the one in year 0 and the one in, so this one is 158. The one in year 5. Okay, so this is the representation of plan number 2. How about plan number 1? Okay, for plan number 1, since we have series of payments, that's why we need to put like this. Because there are yearly transactions, the repayment. So we need to put here 7,712.77 and going like that. Now, since if you are going to put the value in all the arrows here, it will be crowded. That's why instead of putting in all of this, just put here, just draw the arrows and then right at the center, the amount. That is understood that all of these arrows have the value 7,712.77. Okay, sometimes we need to, if the value is bigger, we need to make the arrow longer. But it is not necessarily, it is scaled as long as we represent that this one is bigger. Like for example, we have 29,700 here, and then we have 10,000. Maybe we can do like this, 10,000. So it is smaller than the 29,000. Okay, now let's talk about the end of period convention. So end of period. Now, okay, let me draw another. Okay, what is the end of period convention?
Okay, if you look at this cash flow diagram, for example, okay, we have here, say this is P, and we have a transaction here. So this is year 0, year 1, year 2, year 3. For example, we have this type of transaction. So let's try to understand the cash flow diagram. Cash flow diagram always starts at year 0. Year 0 is also the time now. Okay, so it is today, it is now. So we have here year number 1. In year number 1, that is the end. So this is the end of year 1. And how about this? Here, this is the end of year 2. And this is the end of year 3. So in other words, if you start from here, year 0, we call this as now, year now. Okay? So from this point up to this point is considered as 1 year. Okay? So this is the start. Year 0 is the start of year 1, and it will end here. This is the end of year 1. But take note that the end of year 1 is also the beginning of year 2. So another year, this is the start here. This is the start of year 2, and this is the end of year 2. So this is 1 year duration. Okay, is it clear? So normally, the charging of the interest is at the end of the year. Okay? Like for example, in year 0, you obtain the loan. When are they going to charge you the interest? It is after year 1, right? For example, the charging of the interest is yearly. The charging of the interest is after year 1, at the end of year 1. And the second charging of the interest is at the end of year 2. It is not normal that you obtain the loan now and then they will charge you interest immediately. No, they are going to wait 1 year before they are going to charge the interest of the transaction. That's why the convention is the transaction is being charged with interest at the end of the year or end of the period. That's why we have what we call as end of period convention. Okay, is it clear? But later on, you will find out that there are abnormal transactions. So they call it as abnormal transactions because it is not normal. In other words, the charging of the interest or the interest is being done at the beginning. Okay, the treatment of the transaction is at the beginning of the period. Okay, one example, deposit. Okay, so deposit is being done at the beginning of the period. So how are we going to calculate later on the interest or the earnings of the deposit? Okay, same procedure as the normal, but we have additional procedures. So we treat it as normal with another procedure to be charged. Okay, we will have examples later on when we are going to compute, we are going to calculate transactions. But for now, you try to understand that most transactions that are considered as normal are being charged after the period or at the end of the period. If it is one time, okay, or we call this as deferment, the charging of the interest is at the end of the year. If it is 5 years deferment plan, then the charging of the interest is done at the end of 5 years. But if the transaction is we call this as annuity, or we call this as equal annual payment, or A, and the charging is every year, then the interest is being computed at the end of every year. So that is what we call as the end of period convention. Okay, so let's move on. So that is end of period convention. Now, let's proceed to the methods of calculating interest. There are two methods of calculating interest. What are they? So the first one is called as the simple interest. Have you heard about it? Have you heard about simple interest? So the first method of calculating the interest is called a simple interest. So if we can read here, it says, okay, interest. So the first scheme considers interest earned on only the principal amount during its interest period. Okay, so take note here. The interest is charged or earned on only the principal amount during its interest period. That's why it is called as simple interest. So in other words, the interest earned during its interest period does not earn additional interest. Like for example, the charging of interest is per year. So the interest rate, for example, is 10%. And the period is 3 years. So the principal here is, say, $100. Okay, let's compute it here. Okay, so we have here principal is equal to $100. Our N is equal to 3, and interest rate is equal to 10%. Okay, so at the end of first year, so this is normal. So at the end of the first year, what is the beginning balance and what is the ending balance? Okay, so let's have a table here. Okay, so we have the principal here, or we call this as the beginning okay, so this is beginning balance. This is the interest, and we have the ending balance. Okay. By the way, interest is, as we discussed last time, interest is the cost of money that we charge. And we have the general formula for interest as interest is equal to I, P, N. So that is interest rate multiplied by the principal multiplied by the duration. But if it is by year, if the computation is by year, same as what we are going to do, we do not include the N here because we are dealing it per year. So in year 0, now, what is the beginning balance? We have 100. Since this is normal, the computation of the interest is at the end of the period. Therefore, at the beginning of the period, the interest is 0. So the ending balance is the interest plus the beginning balance. Therefore, 100 plus 0 is 100. So beginning balance is also the P, and the ending balance is also the F. And F here is considered as P plus I. Okay? Now, at the end of year 1, of course, here we say that the beginning balance is here 0, and the ending balance is here at the end of year 1. So therefore, the ending balance of the previous, so the ending balance of the previous is the beginning balance of the next period. Therefore, what is the beginning balance at the end of year 1 or in year 1? So we copy the ending balance here. We put it here. Now, since there is already 1 year that has been passed, therefore we can already compute the interest. Okay, so how much is the interest that we earn after 1 year?
10.
If the if the interest rate is 10, so therefore the interest is 10, okay, and the ending balance is 110. Now, in year 2, this is the ending balance, and therefore our beginning balance here is 110. Okay, if we are going to use the simple interest method, it says that it is only the principal that we are going to charge. Okay, look at here in the definition. It says here, in other words, the interest earned, whatever is the interest earned during its period, does not earn additional interest. In other words, only the original principal will earn interest. Whatever is accumulated or added to the principal during the years, it will not be charged.
So, Doctor,
Is it clear?
in our case, it will be 10 all the years.
Correct. Because what we are charging is only the principal, 100, the original principal. So even if the capital N is 50 or 100, still the interest here is 10. Okay, so it will become now 120, and in year 3, it is 120, but the interest remains the same, which is 10, and this one is 130. Okay, so the ending, okay, the future value of the 100 principal after 3 years at 10% simple interest is only 130. Okay, in other words, we can compute it as, okay, the interest here is I, which is 0.1 multiplied by 100 multiplied by 3 is 30. So that is Okay, that is the interest that you earned for 3 years. Now, to compute for the F, we say that F is equal to P plus I, which is equal to 100 plus 30 equals 130. So this is, okay, that is simple interest. How about compound interest? Do you have any question on simple interest method? The second type is compound interest. Okay, so, well, actually, for simple interest, sometimes it is not any more common in the market. Now, what is being used is the compound interest. But still, we need to discuss about simple interest because the foundation of the compound interest is the simple interest. Okay, so it says here, engineering economic analysis uses compound interests. Okay, look at this portion. What we are going to use is actually the compound interest. How are we going to define compound interest? So it says here, under a compound interest scheme, the interest earned in each period is calculated based on the total amount at the end of the previous period. So in other words, if we are going to compute the interest, we need to include the previously accumulated amount. Okay, it says here, the interest earned in each period is calculated based on the total amount at the end of the previous period. The previous period, the total amount at the end of the previous period, or that is what we call as the ending balance. So in our example here, instead of charging only the principal, the original principal, we need to charge the total amount at the end of the previous period. Okay, so I think I need to put the same computation in the same table so that we can compare the simple and the compound later on. Okay, so I will make in the same table so that you can compare. Okay, so let's compare simple and compound method. Okay, same problem, same value, but this time, what method we are going to use is the compound method or the compound interest. Okay, I will make this, okay, another color. So, in year 0, same, we have 100. This one is 0, and the ending is 100. So the beginning balance in year 1 is 100 also. Same interest, 10, because the total amount in the previous period is 100, right? The ending balance in the previous period, that is year 0, is 100. So that is 100 multiplied by 10% is 10. So we have 110. Okay, we have here 110. But the interest now in year 2 will be the ending balance of the previous year, that is year 1, which is also the beginning of year 2. So instead of charging only the principal, which is 100, the original principal that is 100, now what we're going to charge is the original principal plus the accumulated amount that is 10. Therefore, it is 110 multiplied by 10%. Okay, so what is 110 multiplied by 10%? 11, right?
Yes, 11.
Okay,
Again,
so we
Doctor,
have
please.
okay. Now we are using the compound interest now. So instead of charging the original principal only, according to the definition of compound interest, we are going to charge the original principal plus the accumulated amount. Okay, in year 2, we accumulated already the interest from the previous year, which is 10, right? That's why, what is the amount that we are going to charge? It is not 100, but 110 already. So 110 multiplied by 10% is 11.
Yes.
Okay? And we have now 121. So the beginning balance of year 3 now is 121. And after the end of year 3, okay, what is the amount that we are going to charge? It is 121. So 121 instead of 100 only. So 121 multiplied by 10% is 12.
12.1.
Okay, now we are talking about money. So when we are talking about money, we need to consider the 2 decimal places of the halala. Therefore, even if that is 0, we need to put 0 there. 12.10. Okay, so ending balance we have
33.1.
133.10. So you see the difference between simple method and compound method. So you see the difference?
Yeah, can you
Yes,
write the
yes.
formula for the compound interest, please?
Yeah, later I will put all the formulas. Okay, but this time we have distinguished the difference between the simple method and the compound method. So like Faisal, yes, Faisal, it is accumulative or cumulative. Okay, it is cumulative. So even the amount that we have accumulated from the previous periods, we need to consider that in the computation of the interest in the next period. Unlike the simple. Simple, regardless of the periods, the one that we are going to charge is the original principal. But in the compound, that's why it is called as compound, it is because we are including the accumulated amount to the principal when we charge the interest. Okay? So,
Doctor,
yes, Mubarak.
you applied this PDF after class? Example.
Yeah, I will try to upload this one. Okay, but I'm very sorry about my handwriting. It is not good. I hope you will understand it.
It's
We
clear.
understand that. Yeah, clear,
Yeah.
Doctor.
Well, that is my. They say it is my limitation. Actually, all my brothers and sisters are all technical professionals. I am not. I am the only one who is not. That's why the writing is very good. You know, engineers and architects, they have good handwriting, but when it comes to me, okay, that is their advantage to me. Okay, though when I was in the university, I tried to make my handwriting better because in my mathematics major, I need to do it because my classmates are all engineers and they have good handwriting. So I envy those handwriting and I tried. Okay, so now here's the formula. Okay, for simple interest. Okay, first I'm going to write the formulas for simple interest. Actually, this one is not in your book, but you can derive. Okay, so we can derive. So let's start with I is equal to I P N. And F is equal to P plus I. But it is also P plus I P N. So therefore, we can say common factor is P. So we have 1 plus I N. Correct? Now, suppose it is the P that is unknown. So we are using the these are formulas for simple method. Okay, how we are going to derive P here? So P is equal to
F over 1 plus I
so
n.
it is F. So we move the okay 1 okay, that is how to get the P. Now, there are others, like for example, if we want to, if we want to, if the I is unknown, okay, so we have F over P minus 1 divided by N. And if the N is the unknown, so if N is unknown, we have the opposite. So we have F over P minus 1 divided by I. Okay? So this is for simple interest. Now for compound. Okay, I will put this here. Simple. Okay, now how about the compound? So we have here F is equal to P multiplied by 1 plus I raised to N. Okay, can you remember the transactions that we solved a while ago? Okay, so we have P, which is 100. So F is equal to 100 multiplied by 1 plus 10% raised to 3. So this is 100 multiplied by 1.1, okay, raised to 3. That is equivalent to 131.10. Okay, is it correct? So, sorry, it is 133.
133.
Okay, so 133.10. Okay, so this is to get the F. Now, to get the I, by the way, okay, both the simple and the compound, to get the I, they are the same. So I is equal to F minus P. Now, how to get the P? So P is equal to F multiplied by 1 plus I raised to negative N. Or this is also equivalent to F
over 1 plus I
okay, 1 plus I
to the
raised
power
to
N.
N. Yes. So they are the same. Okay, how about to get the I? Okay, so we have here I is equal to F over P over 1 over N minus N. Okay, 1 over N minus 1. And for the N, we have log F over P divided by log 1 plus I. Okay, so that is the compound and simple interest. Okay, now let's have some simple calculations.
Doctor,
Yes.
these equation will be given in the midterm exam
Yes.
or
Yes, it will be given, but midterm in online, I think, I don't know if I can put the calculated formulas in the blackboard so that you can click only you can click and you can use the formula. But
I think you
since
can put it in the exam instructions.
Actually, teacher, you can prepare a formula sheet and we can print it as a hard copy and use it during the exam.
yeah, but I think in the lockdown, maybe lockdown can it will be treated as like cheating if it sees the paper like that one when you are solving and you are having a paper something. I'm not sure. Okay, I will think about it, but for sure, okay, for sure, you are not going to memorize these formulas. Although these are the only formulas, plus the other 4 formulas later on in the next lessons that we have. So the questions will be typing it is also MCQ. unless they will, because I will submit the questions first to the management, and they will see if it will be all MCQs, or maybe there will be one computation later. But usually it is MCQ. Okay, do you have any question on the formulas before we go to some exercises? Okay, if there's none, let's have some example of problems.